So, okay. So okay, see the same problem, but I took dimension values. So you feel somewhat good, I think. Okay, that's it. That is my intention. So listen. Okay, so Warren Truss. So P Q R S T A B C D E F. So I will took the dimensions as 4 meters, 4 meters, and also this dimensions also I take as a 4 meters. So see Warren Truss, what is Warren Truss means these triangles are equilateral triangles, equitriangles, not equilateral, equitriangles. What is that means of equitriangle? This angle should be equal to this angle. Every triangle is same. Every triangle is same. There is no change in angles. Okay, equitriangles. So the Warren Truss is formed by the equitriangles, same triangles. Are understood? So that's it. I took the dimensions as this 4 meters, this 4 meters. So, and also last class one of your student asked doubt yesterday. That means what he asked is, sir, every time you said it says, see, x into L minus x by L you said, but this dB and AQ, or this AC and BQ, AC and BQ are not A into L minus L. So A into L minus L is covers total length. But sir, if you see, this is a AC and this is a BQ, this is missing, sir. Someone yesterday messaged me. But you can't see x into L minus x by L. So x into L minus x, but you said AC and BQ only. So every time you said, so DB and AQ, these are not fulfilled, sir. So everyone asks same thing. Here also, AC into BD. Sir, it's not exactly x into L minus x, sir. Someone raised the question. But this is the right. So how it is, I will show you. So for that purpose, I will first, you can't understand, you didn't know exactly. So I will show you. So just a small. I will show everyone. If it is a simply supported beam, 1, 2, 3, 4. It's a 2 meters everything. I want a bending moment. At this location. When a unit load is passing, I want a bending moment at this location. So what is that? You already know what you know. You already know this is the diagram, sir. What is this value? This value is 2 into 6 divided by 10. See, so 4 into 6 by 10. You already know, na? You already know how it is come. See, now it is. Just see, observe it. If the load is at this place, what is this value? Reaction. This is 8 by 10. This is 2 by 10. That's it, na? This is 8 by 10, 2 by 10. So what is exactly this bending moment at this location? You have to take it from this side, because it has already this one value is there. So you need two multiplications, no required. So you directly take this C, RB multiply with, this is RB na, RB multiply with 6 That's it now. RB multiply with 6. What is that value? RB is what? RB is 2 by 10. This is 6. So 2 into 6. 2 into 6. 2 into 6. It doesn't exactly, it's not a, it's a 10. You feel now, yesterday I said I shown something. Exactly, it's 2 by 10 multiplied with 6. Not, sorry, not 4 by 10. Because this value is this value. This is the value. This is 2 by 10 into 6. This is a 2 by 6 into 10. If the load is at this place, exactly this place. If the exactly this place, what is this value? This value is 6 by 10. This value is 4 by 10. Now you can take anything. This side, from this side, you will get what is that value? 6 by 10 into 4. Or this side, 4 by 10 into 6. Both are same. Now that is the value of this. Now it's a 4 into 6. It's both are equal, exactly equal to 10. 4, 6 is a 10. Exactly in center you will get the 6 into 4. Those two distances are exactly matching with the total length. Not at every place. Okay. So now same thing. If now the load is at this place. So what is this value? This value is like 4 by 10. This value is 6 by 10. Now you have to take care from this side, because this side is two sides, two values are there, so you will get from this side. So what is this value? 4 by 10 multiply with distance is 4 only at this location. 4 by 10 into 4. See now, 4 and 4, it's not equal to 10. Okay, 4 into 4, 4 plus 4 is 10. We want the bending moment at this location only. So this value is what? This value is 4 into 4. Now what is this value? This value again, it's 4 into 2. It's reducing. Okay, so that means at the exactly what location we required, when the load is present at that location only, you will get 4 and 6, these two values. Remaining values, this is 2 into 6, this is 4 4, this is 4 2. So how we will get this 8 by 10 or 6 by 10, 4 by 10? How it is? This distance, na? So 8 by 10 means this distance. This distance divided by, see, up to this distance divided by total value. So later its load is moving away from that support, the reaction is reducing. Understood? So this is 2 by 6, this is 2 by 6. Now you can understand the previous problem yesterday. See what to understand. See, every time you took the moment with respect to this location. Are understood? Every time you get moment with respect to q joint. Moment with respect to q joint. RB multiply with this distance, or RA multiply with this distance. Sorry, RA multiply with this distance. RA multiply with, that means what? This is exactly represents the moment, the influence lines for the moment at that location. Where is that location? The location is at Q, because every time you will get RA into this distance, RB into this distance, RB into something. Okay, so it exactly represents the influence line for the bending moment at that location. Where is that location? That location is at the Q joint. That's why we will get exactly this representation. Are understood? So these values, you don't get x into L minus x. Only this location, this prime value, this value you will get a q dash 1b by b. You will directly write to the influence line diagram. So what is this value? This value is this value. See, db into aq by. These two doesn't give exactly x into L minus x. Are understood? I will get this value, C value, I will get this Q D value. Understood? But sir, why it is only covering up? So these two I will how they reduce that diagram. So I will show you. Okay. So don't confuse these values. Exactly this dB into AQ doesn't exactly matching the total length x into L minus x. So this total diagram represents the bending influence line for the bending moment at that location. So the prime value you will get directly by AQ into these two. These values doesn't give x into L minus x. Okay, are understood? Someone asked yesterday. Okay, so that's it now. So that's it, you will get this value 4 into 6. So now I will show you. Now I will show you this same thing. What is that? I will take this bottom card CD. Okay, bottom card I will took. Time is less. I will took, I think, 1.5 hour maybe taken. Bottom card, it's a CD I will show you. Okay, so cut it CD. Maybe we will cut it at even at any side. Cut it. So load at this location, there is no load at, there is no load any member, it's a 0. So next take it load at C location. This is 1. If it is 1, what is this value? RA is what? So 4 1 2 3 4 5 20. So 20 na, so only it's this is 16 by 20. It's a 4 by 20. That's it. It's a 16 by 20. It's a 4 by 20. So take only right side because it has only one reaction. So write free body diagram. Write free body diagram at only right side. Okay, so take it how it is look like. Just imagine something. That's it. This is RQ. That's it now. RQ. This is a D. This is a D. Okay. This is a D. Okay. This is a C. This is C. That's it. This is the free body diagram. So this, what is this value? This value is 4 by 20. So we want CD. So we want CD. So how we choose? We choose a Q value because just unbalanced moment for the top chord and bottom chord. We choose a method like we balance the unbalanced moment. Okay, so we choose Q. That's why RQ and DQ are meeting at the joint Q. There is no perpendicular distance. There is no movement created by those two forces because those two forces are entering into the joint C. So only you will get this is a H C. Now write. So CD force multiply with H. So is equal to the 4 by 20 multiply with the distance. What is the distance? This is the distance exactly up to Q. Up to Q, what is the distance? The distance is C. The distance is, this is the distance. This is the distance. Are understood? This is the distance. I call it as this is Q dash. What is the distance? The distance is 4, 12, 12 plus 2, 14. Understood? 14. So 12, this is a 2, I think. So 14. Okay, that's it. This is a 14. So what is CD? 4 into 20, it's a 14 divided by 1 by H. I will call it. So 4 into 14. Sir, we want exactly to be equal to 20. No. See, this is 4 is what? This 4 is this distance. This distance. This is a 4. This is a 14. Sir, this you left something. No, nothing. When you will get exactly this location only, you will get that value. So in between those values doesn't exactly A into L minus A. Are understood? So that's why I give an example. Okay, someone raises the question next day. So that is a 40. Are understood? This is the CD value now. Okay, 4 into 40. That's it. Remove it. You will get na? You will get the what is the force? This is the same tension force. Okay. Now the load is at this location. Now the load is at this location. Now we load it at this location. So you will choose right part as the left part. Choose the left part. Okay. Choose the left part. Okay. So write down the same thing. How it is looks like. That's it. Nah? This is what? This is Q, QR, QR, and this value something is there. Okay, QR, and this is QD, QD. This is CD. Okay, this is CD. This is right. Exactly. So if it is loaded as D location, what is this value? This value is what? This value is 14 by 20. This value is 8 by 20. So now you see here, we see what is this value. This value is RB into distance, Q dash distance. Understood? RB into Q dash. So that is RB. Yesterday we write as RB as 4 by 420. We just taken as RB as this distance, AC divided by total distance. I write 4 by 20. Just I choose values here. Okay, same problem. Yesterday if someone feel that AC something like, if you give notations you can't understand, now we can understand. Now see, this value is what? 14 by 20. Now also what is it? We have to choose same unbalanced moment. Unbalanced moment. What is that unbalanced moment? With respect to same, again we will choose Q, because that QD and QR passes through the same Q point. Same Q point. So there is no moment generated. So again same thing. Again if you same thing, 14 by 40. This is RA. RA multiply with this distance. What is the distance? 4 plus 6. This is 2. This 6. This is going to this direction. This is going to this direction. So CD multiply with H. So what is CD? 14 by 20 into 6. 1 by H. Understood? 14 by 20 into so what is that value? 14. Sorry, not 14, it's a 12. Okay, it's a 12. Not 14. Okay, so if the load is at D location, it's a 4, and again 4. Reducing 4, it's a 12. Okay, sorry, it's a 12. That's it. It's a 12. 12 by 20 into 6. So this is what? This is RA into distance of Q dash. Okay, now you can understand that. Now you can understand that every time we wrote, if you say if you see the load is at this location, same you have to choose the left part. Now is choose the left part, and same equation, and now only the RA is distance. RA is now what is 8 by 20. You will get 8 by 20. That's it. 8 by 20 into Q dash. So this represents the exactly the bending moment location at this point. Are understood? Bending moment at that location. What is that value? So this is, you just remove this value. What is this? What is this? RA into distance. RA into distance. That is a bending moment variation at that location. Is exactly represents. So that's it. So now you can directly write it. The bending moment at this location, the influence line for the bending moment at that location when the unit load is passing, you can write it. It exactly resembles the CD and divide by 1 by H. Okay, that's it. That is the idea. Now you can see. Otherwise, if you see, otherwise you can see when the load is at C value. When the load is at C value, you will get this value. What is that value? So 14 into, so 4 into 14, 4 into 14, this value you can take it. When the, see, this is a 14 into 4, 56. This is 12 into 6, 72. Okay, now when the load is at D, it's a this value. When the load is at E, it reduces. How it is reduces? 8. 8 by, this is going to be 10, not 10. What is that value? So same 6 value. It's reducing. RA is reducing. 12 by 20. Next it's 8 by 20. Distance is same 6. 8 by 6. Next again it reduces to 4 by 6. So this value is 8 by 6. It's a 4 by 6. 4 by 6. 4 into 6. Divide by 20. Okay. So if you join these values, this value, these values are proportional. Exactly, this is proportionality. See, but exactly the C and D in between, if you write down the influence line diagram, you have to join this. When the load is at C, you have to find out. When the load is at D, join. When the load is at E, you have to join. So you have to join everything. You will get like this. You will get like this. But you can write down the diagram directly. How can you say directly? The bending moment at the location of Q dash, you can directly write down. So how can you write down? So exactly, if you see, that is exactly looks like it will come like this. So this is exactly, this is a Q dash. So what is this value? This value is x into L minus x by L. You can write what is this x? This is 6, this is 14. Divide by 20, 1 by 4. You can't miss it. If you write down the directly diagram, later you will join these two values. You will join these two. Sir, why it is joined? Because there is no placing of the loading at the joint of QQ dash. We will get only the load is at Q when the load is at D. But the total diagram we can write down by directly the influence line diagram at the junction of QQ dash, the bending moment influence line. You can write down and you can join the C and D values like this, because there is no joint in between. Understand? The 6 into 14 divided by 20 into 1 by 4. You can write down. So everything is tension force. Understand? So that's why we have to join at C and D. We have to reduce it. There is no joint in between. You can get this diagram by like this. When the load is at C, when the load is at D, when the load is at E, when the load is at F. This is B. You can get this value. But without this, you can directly choose the bending moment influence line diagram for that force in the CD member is equal to the bending moment at that location of the QQ dash, influence line for the bending moment at that location of the QQ dash, divided by 1 by H. You can directly write down. But if you write down and you have to join the CD leg, you already know the D value is higher. D value is higher compared with C. No need at all. If you directly write down the bending moment diagram and you will choose these values CD and you can join it. Understood? So now I think you understood. So now if you see CD, you will write. So DE you can directly write down. No need at all. DE. How can you write it? DE. DE you can write CD, DE. You can write down exactly, take it center. Center means, so this value. Now it's this value. So this distance is 2, 4, 4, 8, 10, 10, 10. Okay. So it's 10 exactly. These are exactly equal. These are equal. Okay. So you can directly write down the exactly both are equal. Okay. This value is 10 into 10 by 20, 1 by H. You can directly write down. And this value is D, this value is E. You can join these two. At C, you will get some value. At E, you will get. At F, you will get. Okay, E already, sorry. So at C, you will get some value. At F, you will get same values. You will join these values D and E, because there is no joint in between this. This is R dash. Directly you can write it. You can get it. So otherwise you will get the value at C, value at D, value at E, value at F. You will get those values and you will join it. No need at all. Directly it represents 10 into 10 by 20 into 1 by 4. You will get it, but this portion is not required. So okay. So next DE. So EF also same thing. You will write it. EF in between you will write it. EF. So same thing. This is like this. EF. So this value is same as it is, 6 into 14 or 14 into 6 by 20, 1 by 4. EF. So you will get F value here, you will get E value here, and D value, C value. You will join those two values. you will get these values. Okay. Okay. So and also you will get these two also. What is that value? AC and FB also. AC FB, how you will get? AC or FB, same thing. AC, how you will get? AC you will get. So in between AC in between you will get maximum, this value. Here you will get maximum. Here you will get maximum. Okay. Here you will get maximum in between AC. So what is that value? In between means this is a 2 into 18 by 20, 1 by 4. So next last again you will get last. 2 into 18 by 20. So this is A. You will get C here. Are understood? In between C here. So you will join this 0 to this value like this. Because A at A is 0 na? Here also you will join these two here. Okay. Here it is C. Here it is F. Okay. So this portion is not no need at all, because there is no joint at this location. Only at C is the joint bottom. So this is 0. This you can join it. Okay. C, D, E, F. You will get these values. Otherwise you will get these values. Are understood? So that is the bottom chord members. Very easy. Same method. Every truss you can take it. It's the same method. No needed no other method. Unbalanced moment you have to join it. Okay. So now we will go to the every member. Okay. This is a joint of AC. This is a joint of PF. So this is a joint of, this is a CD, this is DE, this is EF. Okay. Now is AC and BF. Okay. Now I will go to top chord. This is easy. So top chord I will choose. What is that I will choose? I will choose QR. I will choose QR. Okay. I will choose QR. The cutting is same like this. The same like this. Okay. The cutting is same thing. QR. So what is the 12 reactions? The load is at here C joint, at A joint 0. So it's a 16 by 20. It's a 4 by 20. I will cut this same location. So now just directly observe it. Choose the right part. Choose the right part. So okay. So QR is passing like this. QR is passing like this. Are understood? QD is going like this. So now we choose the right part. So this is like this. This is like this, and this is like this. We require only QR because we want QR na? So which joint you have to take with respect to the movement? We require only QR. So you have to choose the joint of D only, because the two unbalanced forces are meeting this Q joint, because this Q, DQ and DC are meeting at G. So we have to choose the joint D directly. So then at that only you will get the unbalanced with respect to QR. Remaining two unbalanced forces DQ and DC are meeting at the joint D. So directly you can write it. Are understood? Directly you can write it. So now you see joint Q, unbalanced forces, you will just write it. Okay. This is a R, this is a Q, this is a D. Okay. This is a C. This is also Q. We required only QR. We get only the joint D. Are understood? Only joint D. Then only unbalanced movement will come. So what is this value? This value is 4 by 20. You already know. So this is also, you will fix RB. So write down. Write down. So this is going to be this direction. QR also going to be this direction. So QR force multiply with height H plus 4 by 20 multiply with the distance. What is the distance? with respect to up to D. Up to D is what distance? This 4, 4, 12, 12, 12. So 12, this is the distance up to D equal to 0. So what is QR? Minus, you will get C. So multiply with 1 by H. So this is RB, this is the distance up to D. So we will get compression. Understood? You will get compression. This is RB. So see, 4, 12, it doesn't equal to 20. Okay, doesn't equal, say now. So if you see, observe it, same up, top and bottom same. So previously we will get the moment with respect to the joint Q dash, not a Q dash. Now we will get the moment with respect to the joint D. So see, next giant also, if you get the same thing, okay, now you can see, now observe it. Now the load is at Q. Now the load is at giant D. You will get what? It's a 12 by 20. It's a 8 by 20. Same thing. Now you will choose the right part. See, left part. You will choose the left part. So you will get like this. This is this and this value. You will get. So now choose which giant? Now also same thing here. Now also choose the giant D only, because this Q, see, because this force and this force are meeting with respect to giant D, there is no vertical distance. Only QR will be remaining. So now also you will choose this with respect to giant D only. Okay, so choose it, write down. So write down this. So this is Q, this is QR, this is going to be QD, this is also QD. We will choose the giant D only, because these two waiting at giant D. Understood? So now again write down the equation. You will get, this is RA. What is RA? It's a 12 by 20. RA multiply with distance. What is the distance? Up to D only, na? Up to D. What is the distance? Distance is 8. Up to D is the distance is 8. Plus QR multiply with H equal to 0. So what is QR? So RA multiply with 8, 1 by H. So what is RA? It's a 12 by 20. It's a 12 by 20, it's 8. Now we will get, see, 12 into 2, 8, 12 plus 8, 20. So why it is? Because the load is at the giant of D only. Ardhan? We get the moment at that location of this location of D. The load is at the same location. Then only you will get that maximum value. Then only you will get the maximum value. 12 into 8, 96 is the maximum value. Understood? So here also you will get the same negative value. Where it's a negative value. Multiply with 1 by H. Okay. So now if you see, now the later is load is at E. The value is here is 8 by 20. Here is 12 by 20. The same you will choose the left part only. Same cutting. Array, same cutting. Now the same, see, the value is changing only with RA is changing. RA is changing by 8 by 20. Nothing will change. Same, choose the giant D. Every time you choose the giant D only. Okay, so 8 by 20. So now it is choose by 8 by 20. The distance is 8 only. 1 by H. So now the next E is next F. F I choose, you will get 4 by 20 into 8. These values are reducing. Only maximum only at D location only. The load is at D location only. You will get the maximum. Because we choose the moment with respect to the giant D. Understood? These values are going to be reduced. Again, it will reach the maximum at the load is at D. You will reach the maximum at when the load is at D. Remaining values are reducing. So it's the same representing the influence line for the bending moment at the joint D. Okay, understood? So now you choose, if you write down the bending, now you choose the bending moment equation. A, B, C, D, E, F. If you take it, When the load is at A, no, directly if you write line like this, when the load is at D, it's a 12 into 8. This is my 12 into 8. When the load is at E, say 8 into 8. It's a 4 into 8. When the load is at C, 4 into 12, 40. It's a 48. 4 into 12, it's a 48. It's a 96. 64 is very small. So it's going to be like this. Understood? This is the values, na? This value you will get 4 into 20, 1 by 4. But this exactly represents influence line for the bending moment at the location of the joint D. This exactly represents, na? Directly 12 into 8, AX into L minus X by L. You will directly write it. You can directly get it. No need at all. No need at all to do something. Understood? There is no reduction because the giant D is there. We can get the value when the load is at giant D only. So that's why there is no reduction here. Understood? You will directly, you can write it, the influence line for the QR. Influence line for the QR member is equal to the influence line of the bending moment at the joint at that location of the joint D divided by 1 by H divided by length. So for this QR you will get exactly at this location. At the CD you will get this location. Are understood? Interreversible. For this QR, the bending moment at this location of D. At the CD you will get the bending moment at the location of the Q dash. That's it. It's center. So for this C, for this RS, you will get E. For ST, F. For D, R. For EF, yes. Are understood? That is the simple way. That is the simple way. No need at all. If you do it, you will get the same thing. That's why. Okay, are understood? So I write it. So now we can see. I will choose another value for next. Next you will get max at E. For what? It's a QR. It's a RS. So ST will get this maximum. F. What is this value? This value is 16 4 by 20 by 1 by 4. So okay, 16 4. Okay, so 12 CD. Okay, E. Okay, 16 into 4. 16 into 4, not 16. It's a 12. So 8 into 12. Okay, 4. Wait. So what is this value? This is 8 into 12. Okay, this is, you can call it as 8 into 12, anything. So now we can call it as now we can call it as a 12 into 8. So D and E same are. So 12 into 8. It's a, this is 8, this is 12. 8 into 12. Now it's a 12. It's 8. 12 into 8. Now it's 16 into 4 by 20. This is ST. This is ST. Everything is a compression. Everything is in compression. You can directly write it. So now also we write it ST. We can write a PQ also. PQ also you will get at this location C. Are understood? So at this location of the C, you will get maximum. What is this value? This value is 4 into 16 by 20, 1 by 4. Everything you have, don't miss 1 by 4. 1 by 4. Got it? This is a Q or not PQ. PQ. Everything is compression. Get it? Get the idea? So by the dimensions, you will get the values when the load is at the joints at Q, D, E, F. You can find out the values and you join those values. That is the one idea. But overall idea is, if you observe those values, you will get a simple way. This is a represented the bending moment, influence line for the bending moment at that location of the tube. At that location, certain location, maybe D, E, F or C. That is the overall idea. Individual points, individual values, you can get it and you join it. That is a layman's idea. Okay, layman's. I don't understand what is layman. I don't know. So that's it. That's it. Now we will choose everything. Top chord, bottom chord members. I wrote it. Now I will go with the diagonal member. Diagonal members. So diagonal members. It's easy. Again easy. Now I will choose diagonal members as diagonal members. Now I will choose the diagonal members. What is the diagonal member? QC and QD. Both I will choose directly. That's a QC and QD. Okay, QC and QD. Both I will choose because those are the same. How it is same, I will show you. I will choose QC. I will choose QC first. Same thing, the load is at location. You will get 16 by 20. It's a 4 by 20. I will cut like this. I will cut like this. Alright, I will cut like this. So now it. See, I will write only right part. I will write right part only. Okay, I will write right part. See, QC and QD both are equal. I will write right part. The remaining part. It's a 4 by 20. This is a it's a Q. This is a P. Are understood? This is a QC. This is a D point. This is C. Okay, are understood? Same thing. Now you can observe it. Just balance the vertical forces sufficient for the diagonal members. So a QC vertical component must be equal to 4 by 20. Are understood? QC vertical component just for the diagonal members. Vertical force balance. That's sufficient. So now what is this theta, sir? The theta is constant everywhere. You already know this is equitriangles. So you feel something theta is there. I don't know exactly what is the theta, if you know it or otherwise, but we know what is, this is equilateral triangle. This is equitriangle. This distance is 4. We already know every segment, and this segment is also, it's 4 meters. We already taken it. So exactly this is theta. This is 2 na? This is 2. This is 2. This is 4. What is this length of the vertical member? The length of the vertical member is 4 into 4, 16, 4. It's a root 20 na? This is root 20. Root 20. Understood? So now you can see it cos theta. Cos theta. If it's just taken, this is the theta. Or otherwise, cos theta. What is that cos theta by 2? What is that cos theta by 2? So you just taken, this is the only theta. Half part is taken just theta. Just half part is taken theta. Otherwise, if you know theta, otherwise no need at all. Just see. Okay. Just taken, what is that of cos theta? Just half part is taken cos theta. What will get? It will get this height. This height. Understood? This height 4 divided by this distance, the length of that member. Okay, it's a 420. That's it. That is the cos theta. Otherwise you can write down that cos theta equal to height divided by that length of that member na. You can write down length, height divided by length. That's it. That's it. No need data, just see it. Now we can see balance the vertical members. Balance the vertical members. How can you write? QC cos theta of theta. That's it. Must be equal to 4 by 20 because both are opposite direction. What is that QC? 4 by 20 divided by 1 by cos theta. This 1 by cos theta is what? 1 by cos theta is length by height. That's it. That's it. What is this 4 by 20? This 4 by 20 is RB. So RB multiply with 1 by cos theta should be equal to QC. This is RB. This is L by H. Are understood? This is RB into L by H. That's it. That's it. That's enough. That's enough. See. That's enough. See. Now if you see. Now you see the load is at D. The load is at D. Load is at D. What will get? So load is at D. This value is 12 by 20. This value is 8 by 20. Now you have to choose only the left part. Only the left part. Are understood? So left part you can just write it. This is the left part is this part, where it is, and this part. Okay. Left part. Just write down left part. Just left part. Okay. This is 12 by 20. This is 12 by 20. Not. It's RA. You can just check it. RA. This is this is a PQ. This is a, what is that? CQ, CD. So what is CD? CQ. We require QC now. Same thing. You will get same thing. Are understood? This theta. Both thetas are same. Here theta are same because these are the equitriangles. Here now you can balance the vertical force. What is the balance vertical force? RA plus, because both are same direction. CQ cos theta should be equal to 0 or QC. So what is QC? QC is minus RA divided by cos theta. Are understood? So here it's a 1 by L by H. This RA is 12 by 20 or anything. You don't require. You don't see. That's it. So now you can observe it. Again. Now you can observe it. If the load is at E. Same, we have to choose the left part. You have to choose the left part. You have to balance the same thing. If the load is at E. See, if the load is at E. If the load is at E, same diagram. What is change? This is going to be 8 by 20. That's it. Now also same L by H, but this value is 8 by 20. Now if the load is at F, it's a 4 by 20. Only RA is changing. RA value is changing. Nothing is changing. So now you can observe it. The influence line for the QC is up to the load is at Q. See, up to the load is at C. Up to the load is at C. This is equal to RB multiplied with LBH. And also it's a tension. Once the load is at crossing the C joint, it is equal to RA into this secant theta or anything, RA into L by H. But it's a compression. That's it. RA multiplied with RA value is changing. Okay. So that's it. That is the idea. Now you can write down. This. It's a RB. Just RB, RA influence line. RA, RB is changing. RB and RA influence line is 1 and 1. That's 1 and 1. Exactly, this is 1 and this is a 1. But we multiply with L by H. Everything is multiply with L by H. So 1 multiply with L by H, you can get it. This is L by H. What is the L value and H value? Maybe changing for the everything. Now it's a root 20 by 4. No need at all. Just write it. It's RB. See, this is RA. This is RB. That's the RB influence line. So you just this is RB, not RB into L by H. Root 20 by 4 into, that's it. So see, now we can observe it. I call it as this is C, D, E and F. I will mention it. For the QC, up to C joint, the load is at C joint, it's RB multiplied with L by H. RB, and also it's a tension. It's equal to RB multiplied with L by H. RB multiplied with L by H is this value. RB value. So up to C joint, it will go like this. Okay. So once at D joint, it's a RA multiplied with L by H. RA, it's a D joint, it's a RA. This is the value. So the in between this changing. So later it's a RA. Later its RA is decreasing. Na? So 8 by 20, 4 by 20. So it is 8 by 20, it's a 4 by 20 in multiply with L by H. So later it's RA, just vertical reactions. That's it. So up to this is tension force. Later it's a compression force. That's it. In between C to G joint, the load is changing from C to D. It's changing from the tension to the compression. So just join those two values. That's it. Now it is the influence line. What is that influence line? This and this. This is the portion. That is the influence line. Understood? Up to this is RA, not RA. RB multiply with L by H. RA multiply with L by H. So this L by H is how we will get its equitriangle. Understood? That's it. Okay. Now you can observe it. The same QD you will observe it. Okay, QD. For the QD, I will cut like this. Okay. Everything same. I will cut like this only. QD. I will cut like this. The load is at C joint. This value is 16 by 20. This value is, what is that? This value is 4 by 20. Okay. So I will cut like this. The load is at this location. At this location of 1. So you have to write down where? How can you write? Only left part or right part? You have to choose the right part. Okay. You have to choose the right part. So choose the right part. Choose the right part. QD, not a QC. Now it's a QD. Understood? So same thing. You write down the diagram. It's a QD. Write down the right part. This is a cut it. Write down. Okay. One minute. Or I can't imagine the total. Okay, I will write QD. Write down the right part. It's a 4 by 20. It's a R, it's a Q, it's a D, it's a Q, and it's a like C. That's it. Right part. I'll cut it. So same thing. Here you will balance the vertical reactions. Balance the vertical reactions. You will get same theta is same. Cos theta is same. So now we will write down directly QD. This is QD cos theta plus, because both are upside, see, plus 4 by 20. This means this is RB equal to 0. So what is QD? This is RB 1 by cos theta. This 1 by cos theta is L by H. This is a compression. This is a compression. Are understood? This is a compression. Same RB multiply with L by H. RB multiply with L by H. Got the idea? RB multiply with L by H. That's it. So now if you see, now you can observe it. The load is at D. The load is at D. So you have to choose the right part only. You have to choose the left part. Are understood? You have to choose the left part. So what will happen? What will happen? So what will happen? Left part. You have to choose right left part. C. This is a Q. R. QD. CD. So this value is what? This is RA. This value is 12 by 20. The load is at D. See, now also write down theta. So what is that? QD cos theta is equal to the RA. Both are opposite directions. So what is QD? RA 1 by cos theta. This 1 by cos theta is L by H. So exactly it's a tension. It's a tension is equal to this. So what is it? 12 by 20 L by H. This is RA in multiply with secant theta. Tension. Understood? This is the tension. So now you can conclude that later, if the load is at later, see, the load is at E, the same will happen, same tension, just RA value changing. The load is at E, F, same RA multiply with secant theta. RA is changing. So up to the load at C, the QD force is a compression is equal to the RB into cos theta. Up to the later, from the D joint, D, E, F joint, it's RA multiply with secant theta, but it's a tension. But once and again you have to observe it, what is QC? For QC is up to the joint C is a tension is equal to the RB multiply with L by H. Up to from joint D to EF, it's RA into multiply with theta, it's a compression. Now is the same. Now is also the same, but only small change is up to C joint it's a compression, later tension. Up to compression is same RB into L by H. Up to C RB into L by H. Later it's RA into L by H. But such only change is compression and tension change. Are understood? So both the members relating to the joint Q, QC and QD, both get the same force. Both get the same force when the load is at certain point. That QC, QD will get the same force throughout the load is placing, but opposite to the sign convention, opposite to the load technique. Opposite means compression or tension. One is compression, one is tension. So you can write down now. You can write down the same thing. 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 It's a C, it's a D, E, F. If you taken up to same thing, RB into L by H. This is RA into L by H. Same thing, same value, same value, but up to this is a compression, this is a tension, this is a tension. Are understood? Tension, this is a compression, same value. This is a QD. Get the point? So that's why some of the textbooks they represented both in the same diagram. How is represented? So same value, no, same value, counteract, same value. Here this value, maybe this value is highest, maybe same value, same value, the same thing you can get like this, and the same thing. And because both are same, counteract. This is for QD, this is for QC. This is tension, this is a compression, this is tension. You can represent both in the same because both values are same, but exactly counter the mirror image. Mirror image, are you get it? So are you get it? This value same. This is a QC, this is a QD. Got the point? So that's it, that's it. Now you can, now you can draw, now you can draw for the anything. Can you draw? QC QD we draw, QC QD draw, RDRE, you can draw. You can draw, I can draw, I will draw, I will draw for this, otherwise later you can manage it. C, D, E, F, you can draw up to D, up to this. Say RA into L by H, RB into L by H. This is tension, this is compression for R, C, D, RD. RE, RE you can write down, RE you can write down the same mirror image. This part may be small, I think. This value is, I think, up to this. Mirror image. This is RE. This is tension. This is positive. Can I write? So like this you can write down anything. So only diagonal members are missing is these two members. So RDRE, SC, SF you can write down, but the diagonal members are missing only is PA are missing, PA and PC. PA and PC, how can you write, sir? PA and PC same thing. I will write down PA and PC, same thing, nothing more than this. PA and PC also I will write. PA and PC. See, PA, how will you get? You will get up to C. Correct. Up to C. There is no change at all. There is no change at all. See, PA and PC, you will get like this. See, this PA is you will get like this. I will show. I will show. So PA is total compression. It's a total compression. How can I write it? Okay. So, sorry. You will get like this. 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 That is a PA. PA will get like this. There is no change at all. There is no change at all. Total, it's a compression. PA. PC, you will get same thing. You will get PC. You will get mirror image. Mirror image. Mirror image. Sorry. Maybe you can't get same value. Mirror image you will get. It's a tension. It's a PC. You will get it. There is no change at all from tension to compression, compression, tension. Otherwise you will cut it. Otherwise you will cut it, you will get it. Whereas you will get it like this. P and PC, you will get it, you will see. PA is compression. So just see in simple, very minute example I will give. If you just cut it, see PA is what? Here like this. Just see influence line diagram. It is a P, it's A, it's a reaction. Are understood? So every time you see PA cos theta plus RA equal to 0. There is no another equation. Are understood? Directly you will take load is at this location. You will get like this. So always PA is negative. See, PA is negative. Negative of RA cos theta. And also it's multiples of RA only. There is no RB. Are understood? So directly see, no need of writing. RA into cos theta. From 0, at this location is 0. At this location you will get RA into cosecant theta. Are understood? Every time you will get only negative. Negative compression. So otherwise you just observe it. If the load is at this location, it will go this PA is in compression. PA is in compression. So that's why I will mention, see where it is. So every time this PA is equal to of RA multiples of L by H. Understood? This is P, where it is? This is PA. This is RA. If you take in this theta, PA cos theta plus RA equal to 0. So PA every time is negative of secant theta, L by H. At this location is 0. At this C location you will get this value. So remaining every time you will get the same thing. PC exactly mirror image. So you no need of calculation. You will directly mirror image. But it's a compression, it's a tension. So like this you will get the same values exactly for this what is. So TF and TB. TB is every time the RB multiples. But every time is in compression only. See, it's a compression. RB multiples of secant theta, but it's every time is a compression. This is every time in tension. Are understood? That's it. That's my idea. That's the end of the class. And influence lines diagrams for the trusses is ending. So if you take any problem for the influence lines, the same goes on. Very easy, very easy. So many people feel difficulty when I was studying, or my colleagues also see something, but it's a very simple equation. And also I want to tell you one other thing. Whenever you see WARREN truss, some of the WARREN truss also like this. Some of the WARREN truss shows like this also. These members also placed there. This is also WARREN truss. Sir, how sir? If you see, observe it, these members doesn't take any load, because if you see, these two members are straight in the same direction. The third member taken, no load. See, these two members are in the same direction. This doesn't take any load. Sir, why it is placing, sir? It's placing because of the bulking. These two members may be chance to buckling. So to reduce that buckling effect, we can provide the another members like this only, but these two members doesn't take any loads by the truss theory. If you see this type of truss also, this is also a Warren truss because this doesn't take any loads. Are understood? So this doesn't take any loads. That is also you have to observe it. Okay, I saw one type of that load. I confused it. What is this? This is also a Warren type. This doesn't take any loads. Okay, that's that's the end of the influence lines for trusses. If you have any doubts, ask me freely. Like yesterday, one of the guy asked it. Otherwise,